Hello everyone, I am Farhan and this is our 461 final project PID implemented line following robot. The first thing we are going to do is we are going to create a floor. So how we created a floor is go to new, under proto nodes we have objects and then we can add the floor over here. This is how we add the floor and we can do any rotation or translation on that. Next thing we are going to do is we are going to create a robot. This is going to be our blueprint, and inside this we'll create the shapes for our robots, different bases, the wheels and different sensors. Now we are going to add all of these under children, and I'll show you one by one how we added it. First of all, this is our body shape. We added a normal shape and we adjusted the size so that it looks like a car base. And then we have added different distance sensors. We have added one for the left, one for the right, and one for the mid. And under distance sensor we have named them and in their respective order, like ds underscore mid, ds underscore right, and ds underscore left, so that we can implement that in our code. We have changed all the types to infrared of this distance sensors, infrared, and for the right one as well we have named it ds underscore right and we have changed the type to infrared. That's all from me. The next part will be explained by my teammate Jasarat. Thank you.
Assalamualaikum everyone, I am Jasrat Zahin. We have added the wheels to the robot using hinge joints, which enables us to use a rotational model as a device. We have named the wheels as wheel 1, 2, 3, 4 in order to match it with our controller. PID control of the line follower is a method consisting of proportional, integral, and derivative functions to improve the movement of the robot. The robot uses several sensors to identify the line, thus assisting the bot to stay on track. The robot is driven by DC motors to control the movement of the wheels. So we need a path. In order to create a path, we use Tinkercad to create an 3D model of the path. Thank you everyone.
We can make the path in Tinkercad, and we have to just make sure that the height is less than 0.1, and we can export it as a obj, which will be actually the 3D model of our path, and we can just simply import it to our environment.
Hello everyone, Assalamu alaikum. My name is Afridun Rahman. I will explain the code implementation for this line following PID robot. Let's start with the controller. As you can see, we have named our controller my controller 2 here, and at the beginning we have defined the PID error codes, the PID error values, the KP, KI, and KD, and we have named our three sensors DS right, DS mid, DF left, as you can see also in here. We are using get device method to assign the time step values here. We are assigning the wheels from the robot body part, as my teammate has explained earlier, wheel 1, 2, and 3 and 4. We are setting the initial position as infinite and the velocity is as 0. Now we are getting the value of the DS sensors from the left, right, and mid DS sensors from the get value method, and we are printing out them here. At the bottom we have set some if else conditions. So let me explain this. So if our left sensor value is more than 500, it will take the left turn. In the console we can see when it's taking the left turn, the values of the left sensor is more than 500, and similarly in the same result for the right sensor and for the middle sensor basically stays more than 500 every time because it's following the line. When it goes less than 500, so the robot understands that it needs to take either right turn or left turn. So this is how the robot is working here. And the PID values that we have defined earlier, we are calculating them here and setting the left speed and right speed according to that, and then we are setting those velocity to the wheels. Now let's see how the robot actually follow the line. As you can see, the robot is perfectly following the black path, and this is all from us. Thank you very much.